Hello aviation enthusiasts, I'm Jaden and welcome aboard Jetstream Journeys. This is part 2 of how I built my fully functional 3D printed remote controlled Airbus A330. In my last video I talked about how I designed the airplane, and I also talked about how airplanes fly, the science behind them, and I went over lift, drag, weight, and thrust. And I went over how the shape of wing changes the air around it and how lift is actually created. So if you haven't seen my last video, which is part 1 of this series, go check that out. It's somewhere on your screen there. If you see it, click on it. If not, just type in scratch built Airbus A330 design and electronic prototyping part 1, and you will find my video. In this video I will be going over the 3D printing process, the avionics and how I made it work with the aircraft, the troubles I faced making this aircraft during the printing process, and the solutions I had to implement to overcome these problems. By March 5th, 2024, I finalized the design and modeled the engines, places for the lights to go, so I had to make cutouts in the fuselage, the wings, and the tail end, so I can implement 5mm LED lights. I had to create the landing gear just based off images of the real Airbus A330, and I had to modify the fuselage and pretty much the whole airframe so I can add servo motors, because I want to be able to make these parts move and control the airplane in the air. And I want to be able to move the ailerons, the rudder, the elevator, the landing gear, the flaps, all sorts of things I need to control this very large airplane. From March 6, 2024 to April 2nd, 2024, I started focusing my attention on building the avionics for my RC airplane. When I was looking online, I found that I needed light controllers, servo controllers for the control surfaces, and a transmitter and receiver so I can control the airplane remotely. Although because these parts were coming from different countries, from different manufacturers, all found on different websites, they were going to cost $400, which I didn't mind paying for, but then because I had to pay shipping and handling and all these other hidden fees, that jacked up the price to $900, which now I wasn't going to pay. Now that's not cost friendly for me, because I don't want to have to, firstly, I don't want to have to wait this long, because time is not my friend for this project, as this is also a school project at the same time. If you don't know the school project I'm doing, it's called a passion project, and it's basically the things I'm passionate about and put them all into one project. Check out part 1 if you want to know more about that. But secondly, this plane's probably only going to be flown once and then showcased like it is on my ceiling, flashing and just flashing, and sometimes the engines move when I turn them on. So because the price is too high for all of these parts, I decided to take a different approach. And doing more research, I found this device called Arduino. And the one I found on the internet looked like this. It was an R3, Arduino R3 Uno. My bad. Arduino Uno R3, and this is the first one I seen on the internet. And I was like, that's too small, right? It's not gonna fit all the equipment. I need like all the servo motors for the landing gear, the control surfaces like the ailerons, elevator, etc. And I found out that Arduino comes in different models. Like for example, it comes in this nano model. This blue part right here is the Arduino. So it comes in very small models, and then it comes in very large models like the Mega 2560, which I will display on screen here, as I do not have that right now. But it's just a giant one of these Arduino Uno R3s with more pins and stuff. And doing more research, I found that these Arduinos basically can do anything you tell it to. You just have to program it in its language. And this language in question is C++, which I wasn't very good with coding in C++ at the time, or any sort of C language. So I will have to sit down and learn how to code. So that's what I plan to do this month, from March 6th to April 2nd. But in terms of parts, right now I have the Radiolink T8S remote control. This phone stand does not come with it. I glued that on myself in case I want to use this with other devices like remote control cars with camera systems. I have this 5200 milliamp Z battery. Right now I have this tiny Arduino. And I have a bunch of these with my Arduino parts thing. These LED lights. I'm probably going to use the reds, the greens, and the white lights for this project. Although this is still in the development of the Avionics, so yeah. I wouldn't even be able to put this all together yet because I still have to learn how to use the Arduino and learn how to code it. So I found this website. I don't know how to pronounce it, but I'll put it on screen. It's a very great electronic simulation software for Arduinos. You basically just drag and drop the parts you want to put in your circuit, connect it up to Arduino like you're connecting in real life with, I guess you call these like digital wires. And then you just type in your code and you hit play, compiles the code and starts the program. And it's a very great tool for prototyping stuff before you actually go out and buy parts. But I already had parts here, so I don't have to really buy much, except for the Arduino. But at least I don't have to pay $900 when I now can pay $30 and be more cost friendly with the project. And it could be unique at the same time, because if something goes wrong with these computers, I have to send it back for warranty and all this. No, I can either do two things with my airplane. I can get a new Arduino, or I could just code it again, like recode it or reflash it, and boom, it should work again. So it is now March 28th, 2024, and geez, how does time go so fast? But I finally learned how to code the Arduino in C++. It actually took me considerable amount of time. I had to take some time whilst I was in class to learn this code, because it's like learning a different coding language from HTML and Java and Python was a challenge because I'm already used to different coding languages. But learning C and Arduino is probably like the easiest code I've ever learned so far, in my opinion. I can't say for others because I know a lot of other programmers say Python is way easier to learn than C+. And sometimes I can agree, sometimes I can't agree. But I started the 3D printing process and I started slicing each file for the airplane. And slicing in the context of 3D printing basically just means taking an object file. So for example, like the nose of the airplane, taking that digital object and converting it to steps that the 3D printer reads so it can 3D print this digital object into real life. So that's what the term slicing means. So you hear me say that quite a bit in this part. Well, I sliced all the files and then I started 3D printing. And my first issue was that the printer that I was using right now, the Anycubic Viper, was slow. It only prints at 60 millimeters a second. And like I said earlier, time is not my friend because I have deadlines for this project, because this is a passion project for my English class. So I had to get a next printer. So I've ordered one, and April 4th, 2024, that printer arrived. It's called the Anycubic Cobra 2 Pro, and it prints at 500 millimeters per second, and that'll allow me to get this project done way faster, especially this printing process. One of the biggest issues, even with a brand new printer, and it occurred on both printers, was print failures, because many parts were long and thin, like the walls were thin for the fuselage to keep the aircraft as light as possible, and warping occurred, layer shift occurred, and layer separation became a problem, especially on the wings and fuselage section. May 1st, I finished the printing process, and the reason why it took so long is because I do most of my prints when I'm at home, so I could supervise it, and most of the time I'm in school Monday to Friday, and I cannot see my prints. I cannot see what's going on with the 3D printer. In case something goes wrong, I don't want, firstly, the printer to get damaged, but secondly, the filament to be wasted. So then I put my focus back onto the avionics. Wiring everything together was way more complicated than it was in the simulation. Like I had to get jumper cables and like put them into these pins on an Arduino Mega, which is like a bigger version of this. And I noticed like things would break when I run the code for the first time, and I'm like, oh geez. And then trying to debug it is a nightmare because like now you got yourself tied into all these wires, and it's just wires on top of wires and wires. It's crazy. I almost pulled out the hammer and destroyed the Arduino just out of frustration because like coding when working with Arduinos for the first time is, like, in my opinion, it's not an easy task. After doing lots of debugging though, everything worked perfectly. The lights flashed at the right intervals like the real Airbus A330. The servo motors operated the landing gear. They operated the ailerons, the rudder, the elevators. They operated the nose wheel steering, and they operated the flaps, which was amazing because it took me a while to debug and get this thing to work. But I also noticed that the servos had issues, right? But that was just fixed. I fixed that with just PWM, a little bit of PWM tuning in the code, and I had to change the speed of the servo motors so they're not so sluggish when the remote changes PWM. In my next video, I plan to go over like the assembly and all that other stuff, like the assembly and demonstration of, like, I brought it to school and I showed all my friends and I presented it in class, and I plan to go over all that stuff. Like it was pretty exciting when I presented this thing, but that's for our next video. That's for part 3 of this series of how I built the Airbus A330. If you enjoy my content, feel free to like and subscribe, and thank you everyone and aviation enthusiasts for watching my content. Yeah, have a great day, everyone.